Well, welcome. This video we're going to learn how to add resultants or determine resultants of from different forces and also in a rectangular coordinate system and also use their magnitude and direction. So first and foremost we have these two forces acting on a point, and we can call this point, let's call this point, let's go down and make it darker green. Call this point, it's O. All right. So this point O, and it's applying these two forces, maybe ropes or whatever it is. We don't know. At this point, we're just concerned with the resultant force of these two, and we're going to do that in rectangular coordinates. So first and foremost, let's look at F1. And let's look at change. Let's look at the coordinate system. Just analyze and analyze F1. So first and foremost, we have a coordinate system. We have the y-axis, and we have the x-axis. So we know that F1 is going to be somewhat like this. So F1, and F1 is 50 newtons. We also know the slope of this. So we know that if we look up at our picture, we could say it's every time it drops 3 units, it goes over 4 units. Now, you may recognize that this is a special triangle, and this is 3, 4, 5 triangle, which is awesome. So now what we want to figure out is how to break these down into rectangular components. So what we can do is we can find the angle and all that stuff, but let's not do that. Let's take a look at what it looks like. And this would be F1x, and this one would be F1y. So first and foremost, we know that if we do what's called a unit vector, we would understand that it's going to be 4 over 5. So it's 0.8 I in the I direction plus, minus 0.6 in the J direction. Now, with that said, now we can do is we can multiply 0.8 times 50. So let's look at it this way. So we can say that Fx, F1x, is equal to N1x, which is this guy, times F1. So in this case, it would be 40 newtons. All right, we can also do the same thing with F1y. We could say that N1y, which is what we saw here, times F1. Therefore, we get a negative 30 newtons. All right, so what we're doing, if we look up here, we see that there's an F1 in the X and an F1 in the Y. There's also an F2 in the Y, and there's also an F2 in the X. So, and then we're going to add these components up. So let's take a look and analyze F2. So now we've broken the F1 into these two components, and we have the values for those. So let's start looking at analyzing just F2 now. Let's use another piece of chalk. So that looks sloppy. Analyze F2. We have our coordinate system. We have our X and we have our Y. What we're going to do is we're going to change the color of this again. And this time we have this F2. And this F2, the magnitude of this is 100 newtons. We have almost a flip slope. So every time it goes 3 in the X, it rises 4. So basically, we almost have the same unit vector. So we have N2 is equal to 0.6i plus 0.8 j. We do the same thing. We can say that F2 in the X is equal to the magnitude of F2 times the unit vector 2 in the X direction, which in this case would be 60 newtons. Furthermore, we can say that F2 in the Y is equal to F2 times the unit vector 2 in the Y direction, and we would get 80 newtons. So now what we want to do is we want to add these all up in the resultant. So we would say, if we looked at this in vector form, we would say that the resultant is equal to F1 vector plus the F2 vector. But if we break that out into component form, it's actually equal to F1x plus F2x, and that's in the I direction, plus F1 in the Y direction, plus F2 in the Y direction, and that's in the J direction. Now if we have the resultant of that and we add them all up, we're going to get 100 newtons in the I direction plus 50 newtons in the J direction. So what that visually looks like, so we come back up here. Oops. And we'll make this into a blue color. It looks like right out here. You can look at this also in another way, and this would be the resultant. So I'm going to stop here, and now we determine the resultant. We didn't do the magnitude yet, but we determined the resultant, and in another video what I will do is I will continue on with the resultant and also the magnitude.